Hi guys, welcome to Next Gen Student Channel 2. Today we will be discussing about Dehoff 4.3 problem. So we are given aluminum oxide at 25 degrees Celsius and 1 atmosphere pressure, and the volume is also given. So they have given the coefficient of thermal expansion and compressibility. Now they are asked to estimate the molar volume of this aluminum oxide at 400 degrees Celsius and 100 kilobar pressure. So let's see how to solve this problem. So we have pressure and temperature increased. So let's try plotting in PT curve the initial conditions and final conditions, which is a linear curve, but we are not sure what's on a PV curve. So let's see it later. So when the temperature is increased, the volume has increased, right? When the pressure is increased, the volume has decreased. So in this problem, we have both pressure and temperature increased. And now we don't know whether the final volume is increased or decreased. Why am I talking about this? This is because a PV curve helps us to find the final volume. But if you see the PV curve, it's not clear what process that underwent. So if we take the initial and final conditions and plot it, we have the initial pressure and volume and final pressure. But we don't have the final volume, right? So how do we find out the final volume? If it is one of the standard processes like isobaric, isochoric, isothermal or adiabatic, we can find the final volume. But now we are not sure of what process underwent. So what we will do is write volume as a function of temperature and pressure and write down the derivative form of dV, and we will use the alpha beta from the textbook. So alpha is 1 by V dV by dt and beta is 1 by V dV by dP, and we will put them in the equation. So we will have dV equals to V alpha dt minus V beta dP. So in step 1, what we do is we fix the pressure at 1 atmosphere and raise temperature. So this is an isobaric process, and then we'll follow an isothermal process in step 2. So at fixed pressure dP is 0. So we have dV equals to V alpha dt. We integrate the initial and final conditions for step 1, and we have final volume equals to V into e power alpha delta t. So we input the numbers and we get the volume has increased, and at step 2 we fix the temperature and we raise the pressure, which is an isothermal process. So the dt is 0. So we have dV equals to V beta dP, and integrating them we can find the final volume by inputting the final pressure and initial pressure. Final volume is 25.76, which is greater than the initial volume. So the volume has increased in this process.